Today, we're going to take a look at some of the most recent and most interesting stories to break in the field of geroscience, longevity, and life extension research. You're definitely going to want to stick around for this. It's been a while since I did a news video, but we're going to fix that today. A lot has happened in the field of longevity and geroscience in the last few months, and I mean a lot. So today, I picked what I think are the 4 most interesting stories to share. Now, this was a little bit difficult because so much has happened, but I've made my picks, so let's get started. Okay, first up is an item about a new epigenetic clock. These clocks measure a person's biological age as opposed to their chronological age. Chronological age is simply a measure of how many candles a person has on their birthday cake, as opposed to biological age, which measures a person's functional and cellular age. Now, these clocks were developed to aid in longevity research. It's really the only way to tell if an intervention being studied on humans is effective or not. Now, normally, researchers need to wait until an animal dies to determine if something they did extended that animal's life. However, given the long life of humans, that's pretty much impossible. But by using an epigenetic clock to determine a person's biological age, they can see if their age has advanced during the course of the study, or has slowed down, or even if it's reversed and a person has grown younger during the study. But more and more, these clocks have become popular with people who are biohacking their own longevity to track how well they're doing. Up till now, the most accurate of these clocks has been the Horvath clock, which was developed in 2013. But a company called Deep Longevity has created a new clock called Deep Age that is even more accurate. It can estimate biological age with an accuracy down to a 2.77 year margin of error. Deep Age has been trained with machine learning, also known as deep learning, using about 5,000 blood DNA methylation profiles to estimate biological age. Now, according to this study, it's now the most accurate epigenetic clock on the market. All right, next we've got a study where researchers were able to reprogram human cells by 30 years. This study was published on January the 17th of this year. So a little background. There have been a large number of studies where researchers have exposed cells to the Yamanaka factors, which are 4 specific genes that have been shown to take somatic cells, which are any type of cell in the body except ovum, sperm, and stem cells, and convert them into pluripotent stem cells. Now, in previous studies, exposing cells to these factors has always resulted in turning them into stem cells, and this causes them to lose their cellular identities. The problem has been that attempting to expose cells to these factors just long enough to achieve rejuvenation without losing those all-important identities along with their function has so far been pretty much an unattainable goal. Until now. What these researchers did was to expose the cells to the Yamanaka factors just long enough to push them past the point where they're considered somatic cells and into the realm of stem cells, but just barely. They found that the cell retains enough of their epigenetic cellular memory to allow them to convert back to the type of somatic cell that they started out as. And here's the thing. When the cells, in this case fibroblasts, return to being fibroblasts, they return as younger versions of themselves, 25 to 30 years younger. The researchers used the Horvath clock to measure the results, and they found that using cells that were just under 60 years of age at the beginning resulted in fibroblasts that were approximately 25 years old after just 13 days of reprogramming. They also found that the transcriptome, which is a collection of proteins produced by the genes, was also significantly rejuvenated. The researchers refer to this unique approach as maturation phase transient reprogramming, or MPTR. And as it turns out, timing is pretty important. 10 days of exposure to the Yamanaka factors didn't have nearly the effect of 13 days, but 15 to 17 days was too much, leading to cellular stresses that once again aged the cells. Now, as you might expect, there are some substantial caveats. The first being that this protocol is nowhere near being ready to use on humans. In the study, they used donated human cells, not human volunteers, So systemic factors that are well known to have an effect on the human epigenome, such as those found in old blood, were not factored in. Also, although the cells were rejuvenated, apparently telomere length was not. In fact, they found that using MPTR actually shortened the telomeres somewhat. But I think that this study demonstrates that researchers are on the right track, and it won't be long until there are actual interventions that become available as a result of these studies. Okay, moving on. The next study, which was just published this month, has shown that senolytics can help to alleviate age-related cognitive decline. Now, this study was done on mice, not on humans, and they used specifically bred mice that had been engineered to destroy senescent cell populations upon exposure to a drug called AP20187. But having this chemical trigger allowed the researchers to observe what happened when populations of senescent cells are destroyed. And in this case, they looked at the effect this had on the hippocampi of young and old mice. So they discovered that there was an age-related increase in the hippocampus in the numbers of senescent cells that express a marker for senescent cells. Then they treated the mice with either the drug AP20187 or a cocktail of dasatinib and quercetin. And in both cases, they discovered that there was a marked decrease in cells that expressed the marker for senescent cells, demonstrating that there was a significant decrease in senescent cells. They also discovered that both treatments resulted in a marked improvement in cognitive function in the aged mice. The older mice had trouble completing a type of maze used for cognitive testing compared to younger mice. But after completing the treatment, the aged mice could complete the maze with fewer errors and in less time, turning in performances that were more typical of the younger mice. What this study suggests is that an effective senolytic could possibly improve brain health and reduce the cognitive decline that's associated with aging. Now, there are numerous senolytics that are poised to enter human trials this year. Since the accumulation of senescent cells is likely one of the reasons why humans age, there's every reason to believe that these findings might translate to humans as well. And speaking of improvements in cognitive function, here's a study that was published in December of 2020 that's pretty darn interesting. This study describes a new drug that, when administered to animals with cognitive decline, has the ability to restore memory and cognitive function within a few days. It also seems to demonstrate that age-related cognitive decline isn't permanent, but rather that the memories and cognitive function is still there, but blocked by something. So there's a cellular quality control mechanism called the integrated stress response, or ISR. And one of the things that the ISR does is to throttle the cell's protein production machinery after an insult. And by cellular insult, I'm not talking about a yo mama joke. ISR can normally detect problems with protein production after a cell sustains some type of insult. And it responds by putting the brakes on protein synthesis within the cell. Now, ISR is critical for identifying dysfunctional cells, but if the ISR is stuck in the on position in the brain, it can result in the cell losing the ability to perform normal activities. Now, this new drug is an ISR inhibitor, and that's where it gets its name, ISRIB. And it works by rebooting the protein production machinery after it gets shut down by ISR. Recent animal studies have connected chronic ISR activation with the persistent cognitive and behavioral deficits seen in patients who have suffered traumatic brain injury. Now, these studies have shown that treatment with ISRIB in mice who have suffered TBI can restore normal brain function almost overnight. Since the cognitive defects found in TBI patients are often compared to the cognitive decline found in premature aging, it seemed a logical next step to wonder what effect ISRIB might have on age-related cognitive decline. So the researchers studied the effect of ISRIB on the activity and anatomy of cells in the hippocampus of mice after just 1 day of giving the animals a single dose. And you know what they found? Common signatures of neuronal aging disappeared literally overnight. Neurons' electrical activity became more energetic and more responsive to stimulation. And cells showed a more vigorous and resilient connectivity with neighboring cells, while also showing the ability to form stable connections with one another that's usually only seen in younger mice. They also found that ISRIB alters the function of the immune system's T cells, which are also susceptible to age-related dysfunction. Since diseases from Alzheimer's to diabetes have been linked to elevated inflammation caused by an aging immune system, this study suggests another path that the drug might take to improve cognition in aged animals. If you enjoyed this video, then you may want to watch the rest of the news videos in the news playlist, right here. That's it for me. I'm out of here. Catch you next time.